Now there's one more thing that we could do in Excel that is useful to us. That process of finding our u prime r prime didn't take too long, but maybe we're not necessarily interested in the whole function, but maybe we're more interested in what pieces are moved by the function. And that can be done without completing everything that we have here. So first, let me show you, now that we do have this function, what we could do to highlight the values that are moved by this function. What we could do here is highlight this row, and we could come over to conditional formatting, highlight cell rules. We want more rules because we want to create our own rule, in fact. We want to use a formula to determine which cells to format. And what we're going to do is actually quite simple. We're going to compare the value that's sitting in row 2 with the value that's sitting in row 7. And if those two values are not equal to one another, then that is a sticker that is moved by this motion, and so we'd like to highlight it. So all we have to do is check, is the value in B2 equal to the value in B7, and apply that rule. Now, since we want the 2 and the 7 to always be the same, but the letter may change, we're going to put $ on the 2 and the 7, and we're going to remember that Excel's not equal command is a less than followed by a greater than. Let's go ahead and pick a color for the fill of the cell, and we hit OK, and there it goes. It highlights the values that are not the same once we've performed this motion, so we could get an idea of the stickers that have moved and the stickers that have not moved. Now, last but not least in this video, I'd like to show you how we could do that without actually computing r primed, u primed, and this full composition. So let's just take a look at if I had this r, and in fact, I never have needed even compute u primed. I could just take u, because all that matters to me are the stickers that are moved by r and by u. U primed and r primed will only move stickers that were moved by the original functions, since all we do is undo what has been done by the original motion. So if I wanted to, I could have a little column here for r and a little column here for the original u, which I can take from this sheet and put it right there. We're going to do the same thing. We're going to be applying a filter to this row to highlight the cell. So I'm going to go back to highlight cell rules and use a formula to determine this rule. And all I'm wondering about is when I apply the motion of r to this value, will that value be something that is moved by u? If I move this sticker to a position that is ultimately moved by this function, then I'm in a danger zone. I've been moved somewhere that is affected by the u or the u prime motion. So what I need to do is another comparison on if two cell values are equal, but what I'm going to be checking for equality is, after I've performed the r motion, is this number moved by the u map? So it's just an H lookup. What I'm looking up is the value in B11. That's the output after I apply the R motion. And I'm looking that up in the table B10 to Y12. I'd want the output after U, which would be the third row of that table. And I would want an exact value there. So what this number is going to be is actually R composed with U. And what I want to do is check whether or not that's equal to the R value. If those two things are not equal, then in my original row, I'd like to highlight that value. And let's go ahead and apply that filter. And notice that the things that are highlighted are exactly the things that were highlighted up here. So it's a little shortcut if all you're looking for is what numerical values are affected by that composition and you're not actually looking for the breakdown of what that function is. Last but not least in this video, I'd like to emphasize just how powerful conjugates are. Now, there's a whole category of people who not only solve Rubik's Cubes, but solve them incredibly quickly and solve them blindfolded. And the huge trick that they're using, especially with a pocket cube, is that there is one permutation of moves, one motion of moves. It looks rather long when you write it this way, and it's called the Y permutation. But if you break it up into conjugates, you'll notice that this big, long Y permutation is just 5 conjugates altogether. And they have this particular form, the first of which we just spent a lot of time figuring out what it was. So it's 5 conjugates done in a sequence, and this Y permutation moves just 2 spots on the pocket cube. And it's very powerful because in fact what blindfolded pocket cubers are doing is using conjugates of this Y permutation to solve the entire cube. So you can imagine that you could get to a place where you could do this blindfolded because all you have to do is memorize one particular move, which is just 5 things if you think of it in terms of conjugates. And then if you glance at the cube, you can just come up with how you would have to move particular cubes to get them into the spots that are affected by the Y permutation. And you could do this motion and you'd fix 2 cubies at a time. So you really would only have to do 8 Y permutations at most in order to solve this Rubik's Cube. And you could get to a point where you could hold that in your head. So conjugates are in fact so powerful that the entire pocket cube can be solved by the right types of conjugates. And you could get to a point where you could do this blindfolded once you master conjugate on a pocket cube. So conjugates are hugely important, and it's worth spending the time that we've spent on them to get familiar with them and to start understanding them, because they can in fact solve all 3.5 million configurations of a pocket cube.